Welcome back, friends. In this video, we'll make our version of a word game called Hangman in Scratch. Now, this is an interesting game, and I'm quite sure sometime or the other you have probably played this. Let's see how this works out in Scratch. So here we have the Hangman game. So computer has chosen a word for us, and we have to now guess it letter by letter. It's a five-letter word. So let's just try. I usually start with the vowels. So A, there's no A in this, so it doesn't show up. And notice that the Hangman costume starts to become bigger, right? Now I'll try E. Okay, there is an E on the fourth position. Uh, okay, A, E, O. There is an O as well. I. There's no I, U. Okay, so it's not also there. I'm going to try my regular consonants. Uh, R, S. Okay, so S. Right. So this is could be S. A, no. Okay. Okay. Let's try H here. All right. I think I have some idea of what this might be. So I'm going to try a P, and indeed, this was a P. So the word was hopes. So basically, this is how the game works. Let's take one more example. Once again, the computer has chosen a word for me. I must guess it now. So let me just start with regular A. There's no A. There's E, I, O. Yes, there's an O. U. There ain't any U. So okay, I'm going to try my regular R. All right. S. Yes. Trots. T. L. Uh, okay. So, okay, I'm going to try N here. Unfortunately, I didn't get it. And notice the word was gross, right? So that's how the game goes. It's quite interesting, quite, involved. Now we are going to build this game in Scratch. However, I'm not going to start completely from scratch. In fact, I have made a small, basically like a skeleton here. And what I have done here is that I have three sprites, letter sprite, where I have already created the text engine that we spoke about, right? So this guess the word. The text engine is needed because we are going to write all these letters, these phrases, and so on. So I've already created that. I have also created the Hangman sprite, which is a very simple sprite with multiple costumes, right? So notice the game starts with this at costume number one, but really this has multiple costumes with each costume progressively becoming like the complete Hangman. So costume one, costume two, costume three, for example, costume four. If you go all the way down to costume eight, then that's the complete Hangman. I mean, it's not very attractive, but it serves our purpose for now. Also here I have created and already done the code for this letter space, which is basically these marks, which on which the letters get written, and it looks nice, right? So this letter space, the code is very interesting. Very simple actually in a way, because it's very similar to, for example, the buildings code in the memory game that we have done, or let's say the whack-a-mole and brick breaker, where we did this two-dimensional bridge, right? The only difference is that previously we used to use cloning, but here I'm using stamping. So I say set x to -100, set y to 20, so that's the x and y position. I repeat five times. I make five stamps of this particular, this particular letter space, and every time before I do that, or rather, actually, after I do that, I change x by 50, right? So that I get this nice five, let's say, placeholders for my letters. So this part is very simple, and on the main letter code, I have already got this is I erase everything. I broadcast this create line so that those lines get created, and I then write guess the word at say -120, 120, right? So if I just click the flag, I kind of start at this point, right? The only thing I want to highlight at this in letter space thing is that notice that I'm using stamping, like I said. Uh, and that's really because the same reason as in the text engine, so that the stamps remain visible. Also, I have this extra hide in the end. Right now, what happens if I do not have this? Let me just show you. If I did not have this, then what happens is that I get an extra mark coming out. And why does this happen? Because remember here, the original sprite is shown, and after the stamp I change x by 50, right? So basically this is the original sprite that's showing up. So in order to avoid this, I must use an extra hide in the end, right? So if I did that, I get this particular five letters as I would like to. All right, so let's get started building this further from here. Now you can imagine that the first thing that you need here is a very, very huge list of words, right? Now, the reason we need a huge list of words is because the words that the computer chooses come from that list, and if that list is not very large, then you'll start guessing them very easily, right? So you can look at the internet to get, let's say, a five-letter word, a list of five-letter words, but we have also made it simple for you. You can in fact get it from our website, and I'll show you just how to do that. But before that, I'm going to create a list in this game. I'm just going to create a list called, I'll make a list called, let's say, list of words. Right now, this is my master list that will get created. Now, notice what happens is that the moment I click, and let it be for all sprites, the moment I click OK, this list gets this list appears here. Now in this project, I'm going to import this list from elsewhere, right? So what I'm going to do is that I'm going to use this right click and say import, right? But what do I import? Like I said, we have made a list available for you on our web page, right? So go to our website here, for example, ybyte.in advanced class course material. Scroll down all the way to the Hangman project, and you'll notice that there is this this list here called five-letter words. Now you can right click on this and say open this in new tab. This is saved on a Google Drive, so you should be able to see this file over here. Now once you see this, so notice this is like a huge list of words. You can download this, and once you download, it gets stored onto your local computer, right? Now once you have done all this, you can go back to your Scratch project, and just like it showed you earlier, you can go and say import, and you can import this. It's called five-letter words new, and you can just import this list here by selecting the file and clicking open. Now once you do this, notice that suddenly you will have this huge list of 5,752 words, and each of these words is basically a five-letter word. The good thing with importing is that you just have to do it exactly once, right? Which means now that I have done it, even when I close my Scratch and let's say reopen this some other time, this list will always be a part of this. So I do not have to do this again and again. This is just a one-time effort that I do, right? So with this, I have a list from which I can now start picking up words. Now for my game to proceed further, I'm going to get my computer to choose a word from this list, right? So for that purpose, I'm going to create a new variable. I'm going to call it chosen words. Chosen means because the program or the computer has chosen it for me. So I'm calling it chosen word, and I'm going to set this chosen word to a randomly chosen word from this entire list, right? And that part we have done many, many times. So I'm going to say set chosen word to this is a list here, so I can just say item. So I use this word item one of list list of words, but obviously I do not want just any one item. I want a random item from one to say length of list of words, right? So let's make sure that I get a random word every time, and that keeps the game interesting, and that's why the list also needs to be fairly long, right? So if I did this, this looks intimidating, but if I just showed you what's going on now, if I click the flag multiple times, notice I get a new word every time, right? And this word is just coming from the list that we have, right? So now the game is sort of ready for to proceed because the basic infrastructure has been created, right? Now this list of words I do not need to see. This game in fact works in a very interesting, like very nice way, in a way that there's only two possibilities, right? So what happens really is that all the times the user has to enter a letter, and there's really only two possibilities. One possibility is that the letter that the user entered is part of this word, in which case we display, we process further, or it is not a part of this word, right? In which case the Hangman sprite sort of goes to the next costume, and eventually when all the costumes run out, then the game gets over, right? So for us to sort of develop this in a systematic manner, I'm going to give you a sort of a top level structure first, right? So for that purpose, I'm going to create a variable here, right? I'll go to variables here, and I'm going to make a variable here called game over, right? Now the idea is that game over will become one the moment game has to get over, otherwise it will be zero, right? So we'll start with this. We'll set, when the game starts, I'm going to say set game over to zero, because game is obviously not over. and I want this game to continue until the game over becomes one, right? So what I'm getting at is that I'll use a repeat until block, right? So I'll say repeat until game over becomes equal to one, right? So repeat until game over is equal to one. And what do I really do? Like I told you, the game basically is about getting the user to enter a letter, right? Which means that until this game over has become one, I must have a facility for the user to enter a letter, and I do that using the ask block, right? So I can just go and put ask, let's say, guess a letter and wait, right? So I'll say guess a letter and wait, right? So if I did this, there's always going to be an answer box available here. Now, like I said, there's really only two possibilities. One possibility that the answer that the user guesses is part of the word that it has been chosen, or it is not a part of this word, right? So I'm going to put here an if else statement. We'll fill this later on, but let's just put the top level structure first. I'm going to put an if else statement here, and uh, so if else is like a T junction. If this condition is true, I go here, otherwise I go here. Now this condition here, I'm going to make it the situation where the letter that the user has entered is part of this chosen word, right? And how do I do that? Well, I can use an operator here, right? And the operator that I'm going to use is a little bit down here. It's this word, it's this block called apple contains a, right? Which is basically like, if this word here contains this letter, right? Now, in my case, what I'm going to use is that if the chosen word contains the answer. Now remember, whatever the user enters through this text box gets stored in this variable called answer. So I'm going to say that, okay, if the chosen word contains answer, so that means that the user guessed it correctly, else the user has got it wrong, right? So we can just add a small comment here. So say correct uh, guess, or in this case we'll add a comment that it's an incorrect guess, right? So now if the user guesses correctly, we do something. If the user guesses incorrectly, we do something else. In fact, we find it easier to develop the code for the case where the user does not enter the answer correctly. But before I go there, I just want you to realize that even though any word, right, any word or any string is not a list, if you look at these operators, in fact they have very similar features compared to, say, a list operator, right? For example, item, like we have this item something of a word. Here we have letter something of the of the item something of a list, and here we have letter something of a word, right? Similarly, we have length, and we have this apple contains a, right? Now this is the reason for this is because any word or any string can be also thought about as a list of characters, right? So these individual letters combined together, or say space bar and so on and so forth, they sort of form a list, right? So this is an interesting piece of let's say way to think about it, that this is also like a list, and which is why these functions exist, right? Now, like I said, we are going to first do what happens if the user doesn't get correctly. Basically, the point is very simple. If the user doesn't get it correct, then the hangman, must become sort of activated. So what I'm going to do is that I'm going to here, let's say, broadcast a new statement. I'm going to say broadcast. I mean, if the user doesn't get it correct, so I'm going to say broadcast, let's say, wrong answer and wait. Now on the hangman costume, when I start the flag, I obviously go to costume number one. But when I receive, say, wrong answer, so when I receive wrong answer, I must now go to my source, let's say the next costume, because I'm going towards becoming the full hangman. So I should go to the next costume. But before that, I'm just also going to play a small sound. Now I'm going to use this sound called toy honk, but importantly, I use this thing called start sound because I do not want the game to get interrupted, right? This is an event sound, so just everything moves on while the sound is played, right? That's why I do not use play sound until done. Now I use, say, a next costume, so that it goes to the next costume. And also, if the costume has already reached the last costume, which is costume number 8, then that means that the game must be over, because it means that the user has used up all his chances, right? His or her chances. So which means that I'm going to put this operator here. This should be 8, and here the left side should be costume number, right? So if the costume number is equal to 8, it means that the user has exhausted all the chances that they had, which means that now I can set game over to 1, right? So over here I can say set game over to a 1, and notice that the previous sprite, I mean in the letter sprite, everything is set up until game over is equal to 1. So which means that the moment I go to the last costume of the hangman, and I see that the game is over, this loop is also going to exit because this variable is for everybody, right? So here I can also put a comment that this is for wrong answer, right? So wrong guess. So it becomes a little bit easier to read. Now let's just see this in action. Right now, nothing will happen if I enter correctly. So no matter what I enter, it's always going to be basically incorrect. I mean, in the sense like if I enter something, even if it's correct, nothing will happen. But if I enter wrongly, then something should happen, and we just deliberately enter wrong values here, right? So it's called. Let's say take another word. Say, okay, let's say some word that's a bit more familiar. Let's say okay, some of these words are quite rare. Okay, moves. Now let's say the word is moves, but say I start entering A. A is not there, so notice my hangman goes up. I try B, let's say B. B is also not there. I just try let's say C. Let's say F. I'm deliberately putting words, letters which are not part of this word, so that I can see the hangman coming up. I can just notice the moment the hangman becomes complete, the game over became one, and in fact the answer box also went away because this repeat until did it stop, right? Now we have seen what happens when the letter is incorrectly entered, right? Next we are going to go to the point where the letter is correctly entered. It's a little bit more involved obviously because we have to now process this letter and do a bunch of things, right? Uh, so before we start, actually writing the code, I'm just going to show you the steps that we are going to follow if the guest letter is part of the word, right? It's important to keep these steps in mind so that you have a view of where we are going, right? While we develop all this code. So the first thing that we do is that we find if the letter, we know that letter is part of the word, right? So we first go and find all the occurrences where this letter occurs. Notice that some letters might occur only once, some letters might occur twice, and so on, right? So we find all the occurrences of where this letter ends up, and we create a list called occurrences with this. Next, we display the letter at the correct positions on the screen as it was doing. So as the game proceeds, so the user knows what's going on. Next, we update the answer that has been guessed so far. Update the word that has been guessed. This should be guessed here this far, right? Now, what do I mean by this, right? Basically, the user is entering letters. Sometimes the letters are part of the word, sometimes they are not part of the word. But at all times, I must have a view of what the word the user is guessing. What is the state of this word at any given point, right? And then finally, I must check for completion, which means that I must check if the guessed word, whatever word has been formed by the user's guesses, has become equal to the correct, I mean, the chosen word, right? If that happens, that means the user has won, and again, the game over has to become one, right? Now, I'm going to write one my block each for all these three, and this will be done by very simple logic, right? Now, let me just give you an example here so that it becomes a bit more clear about what we are trying to say. Let's say the chosen word is apple and the user enters E, right? Now, notice I'm only considering the case where the letter is part of this word, right? So let's say the user enters E. Now, we know that the letter E exists on position number 5, right? So we are going to create a list called occurrences in which we'll have just 5, right? And we are also going to display this letter for the user at the last position, the fifth position. So notice 1, 2, 3, 4, 5 at the fifth position. And also we know that the word that has been guessed this far is everything empty here, but an E at the end. Similarly, let's say the user enters P. Now, letter P is part of two places. It occurs at two places. The places are 2 and 3. So it's 2 and 3. It's APPLE. So 1, 2, 3, 4, 5. So the letter occurs at 2 and 3, which means that the list occurrences will have 2 and 3. We'll display the letter P at the positions 2 and 3, and also the word that has been guessed this far, assuming the user did this first and then this. The guessed word that has been guessed this far is a space PP space E. Right now, we are going to use this. We are going to keep forming this word letter and then compare this against the chosen word. All right, so back to my program. Now, the first thing I'm going to do is to create a my block, and I'll call this my block find occurrences, right? So I'm going to say find occurrences, which means where all does this, letter occur. Find occurrences. So I'm going to give it a label, say, find occurrences of, add an input letter, add a label text in, and add an input word, right? So what I want to do is that I want this my block to find out for me, given a letter and a word, where all this letter occurs in the given word, right? So that's the whole idea. That's why I've tried to make it appear a little bit intuitive as well. Find occurrences of a given letter in a given word, right? And mind you that we know that this letter exists because we have already made this check elsewhere, right? Now, this is not very hard. It's almost like a list. Like I said, these words are just like a list. So what I'm going to really do is that I'm going to just look at every letter in this word and see if that letter happens to be this letter that is being asked, right? However, like I said, I'm going to store this in a list, and here I'm going to create a list here. So I'll just make a list and I'll call it occurrences. So I'll call these occurrences. Now, in this situation, basically the idea is that wherever the letter occurs, I'm going to store that in the list. So, for example, in the previous case, I had the word apple and I chose P, let's say. So the letter P appears at positions 2 and 3. So occurrences should have 2 and 3, right? Now, notice that the user enters a letter and it must be checked once the letter has been addressed, when entered, right? Which means that the moment this function is called, moment this my block is called, I must first go and delete the entire list occurrences, right? So notice I'm not doing this all the way in the beginning, but I must do it here for the list to be formed again, because every letter has to be checked again and this list must start clean, right? Now, once I've done this, in fact, this is quite simple. We can do it first let's do it in a rather long way and then simplify the code after that, right? So I can argue that if, let's say we have 5 letters in the word, so I can just say, if, let's say, I use this operator letter 1 of apple, so I can say if, letter 1 of apple, let's say, is equal to sorry, letter 1 of the word is, so I drag in the word here and drag in the letter over here. If letter 1 of the word is equal to letter, then I can say add 1 to occurrences, right? So I can go and add to the list here, and I can say add 1 to occurrences, right? And this logic is like very simple. If the first letter is part of the word, I mean, rather, first letter occurs at the first position of the word, which means letter 1 of the word is equal to letter, I can just add 1 to occurrences. Now I can keep duplicating this. I can say that if letter 2 is part of this, this word, then add, say, 2, and so on and so forth. But then this code gets very clumsy, and if the words are long, then it's going to be very, very painful. A lot of mistakes can happen. So we'll not do this. In fact, we'll write this in a lot more concise manner using a counter variable. Right now, we have seen this counter variables. A variable just helps us traverse through a loop, right? So loop with a variable is what we're going to create. I'm going to create a variable here called, say, cntr, just for the sake of display here. So I'll say set counter to say 1, set cntr to say 1, and thereafter I'm just going to repeat this operation by repeat it for the length of words, right? So I remember this words are just like lists, so I'm going to say repeat length of word, right? So if it's a 5 letter word, then it's going to get repeated 5 times. But importantly, I must make sure that this, I can't be checking letter 1 all the time, so I'll make sure that this is checking letter counter, and if the letter is indeed present, then I add counter to occurrences, right? I mean, this is really, if you think about it, just a more concise way of doing this in the previous code. But I must make sure that the counter increases because I want to check every letter of this word, right? So basically, the letter could be present in 1 and 5, could be present so many places. So I must check exactly every letter in this, in this word. So I'm going to say change counter by 1, right? All right, so now we can see this working, but obviously we must first call this my block in the code. So I'm going to just go back to the my blocks here, and I already have the definition. I'm going to say find occurrences of. Now, what should I find occurrences of, right? So I'm going to find occurrences of the answer in the chosen words, because remember, answer is the letter that the user provided, and the chosen word is the word that I'm interested in, right? So I'm going to say find occurrences of answer in chosen word, right? Here. Now, when I do this, now let's see this working. So let's say I select this, and let's take a word which we probably understand. So let's say lover, right? Now, word is lover. Now, if I chose L, notice my occurrence is 1. That's because the letter L occurred on the very first position. If I chose, let's say, E, my occurrence is 4 because the letter E occurred on the 4th position of this word, right? We can try this once again. Let's say Grace. So I try, let's say, Y here. I get 4 because y occurred at 4. Let's try a word where there's a repeated letter. Okay, so did I get one? Jump. There's so many letters in this. It's okay. I actually had one just now. Sides. Let's try sides, right? Now, in case of sides, I have got S, which is on 1 and 5, right? So if I click this S, I should get 1 and 5, and that's exactly what happens, right? So now this list here is telling us the, the all the occurrences of this letter in the word, right? Now let's pause here and go back to the scheme. So we are done with the first part, which means we have found all the occurrences of this word. I'm sorry, of this letter. Now we are going to move to the next part, which is to display the letter, right? This is in fact not very hard because we can just use our text engine to place the letter at the right X position. Let's see how we do this. So as I mentioned, we can use our text engine to place the right choose the letter that has been selected at one of these positions. Now what are these positions? Well, we need to create them in a list also, because the letters must be placed at the right X and Y value, right? So I am going to create a list here called X positions, and I'm going to use something very similar to what we did in the memory game, where we stored the X positions of the building in a list. So I'm going to just create a list here, call it X positions, right? And I'll let it be for all sprites, but the main part where this list will be updated will be in the letter space sprite, which is that I will, when I basically start, let's say when I start this code, I'll delete all of X positions, because that's always a good practice. So I'm going to say delete all of X positions. Here I'll say delete all of X positions. And now in this list, whenever the stamp is created, I keep adding that X positions, that X value to the X positions, right? So just go and say, let's say add over here. Now I must do it before the stamp changes. Otherwise, as you can imagine, this whole thing, before the X changes, otherwise there'll be a problem, right? So I'll go and say add, let's say X position to X positions, right? So here I'm going to drag this X position to X positions, right? Now this is very, very similar to what we did in the, let's say, the memory game and so on. So if I just look at this, if I click this, notice my X positions are minus 100 because that's where I start, then minus 50, this increase of 50 is minus 100, minus 50, 0, 50, 100, because those are the X positions of these, let's say these marks, right? I do not need to worry about Y because I'm just going to write them, my letters slightly above this Y, right? Now with this list available to me, in fact, now I can go back and create my next my block, which is going to be called, say, display letters, right? And we'll see that. And in fact, that's basically going to make use of a text engine. So what do I display a letter here? Now remember that I have to display the letter at the positions which are corresponding to the occurrences, right? So if the letter, for example, appears at 1 and 5, I must display the letter at 1 here and at 5 here, right? Now, the X positions of this 1 and 5 is captured in this list, right? Which means I must display the letter at the X position corresponding to the first item of this list and to the fifth item of this list. So that's the whole idea we're going to follow. It'll become clear when we write this my block. So now let me create a display, display letter my block. So I'm just going to create make a block display letter, and I'll add an input called letter over here. Right now, like I discussed already, that the idea is to traverse to the list of occurrences, go through every element of this list of occurrences, and find the corresponding X positions and display the letter, right? So for this purpose, I can now start writing some code for this. Now, as you know, I'm going to have to look at every element of this list, just like we were doing it earlier, which means that this is a right case for me to create another counter variable. So I'll just create a variable here. I'll just say, in fact, I can reuse this variable because I'm going to call this function define occurrences. Display letter after define occurrences, right? So even though the variable is used here, I can actually use this, or I can just create a new variable. It's not a problem. So I'll just call it, say, cntr1. Just be careful on, let's say, this. It's also a counter variable. So I'm going to say set cntr1 to say, let's say 1, because I just want to go and look at every element of the list occurrences, item 1, item 2, item 3, item 4, and item 5, because it could be potentially 5 occurrences also, or whatever, right? So I'm going to say repeat length of occurrences, say repeat length of, in the variables, I'm going to say repeat length of occurrences. Now, what I want to do is that I want to make sure that every element of this list is checked. So I will and wherever I find, let's say for example, first element is 1, so I'm going to find a corresponding X position and display the text, right? So for displaying the text, I'm going to call in my text engine block, which is write. So I'll say write, let's say this letter at the X value, which is given by this item of the X positions list. So for example, in this case, item 1 of X positions, or say at item 5 of X positions, right? So be careful on what's going on here. So I'm going to say, I'm going to use a rather complicated looking statement in the variables. I mean, in the list section, I'm going to say item inside an item. And that's because the first item, refers to the item counter 1. So let me just put this at item. Okay, item of, so let's be careful here, item of X position. And okay, what should this item be? This item should be item counter of item cntr1 of the variables. I'll go and say item cntr1 of occurrences, right? So notice I'm basically going through every item in this occurrences, and in that right X position, I go and display this particular letter from the X. I mean, I basically pick up the element from the occurrences, go to the X positions list and display this. And for the Y, I just put 40 because I know these letters occurred. I mean, these letters were put at Y equals to 20. So I just put them slightly above this letter, right? Now, most important thing here is that I must change counter 1 by 1 because only then it will repeat through the entire list here, right? Now, let's see this in action. But before that, I must call this letter over here. So I'm going to just call my block here and display letter and letter, because the other part is a display letter answer, right? So the other part is taken care inside the my block, right? Now if I did this, let's just see if this works. So let's say the word is let's say take a word which we use a bit more familiar. uh, let's say incur. Okay, rural, right? Now the word is rural. Let's say I select the letter A. Now I know A occurs in the fourth position of this words, 1 2 3 4. So I should expect occurrences to become 4, and occurrences becomes 4. Then I call this display. So it goes to the occurrences. It says, okay, I'm going to put this A at item 4 of expositions, which is this 4 number, right? So it'll because expositions contains the right expositions, this will make sure that the letter A goes here. Now I can try the letter R. Now letter R is present in 1 and 3, and hence I first create the occurrences 1 and 3, and then I use these indices. So like item 1 of expositions is -100, first one here. Item 3 of expositions, which is 100, and the second R appears here. So that's how this thing works, and you can convince yourself that this is indeed correct. All right, so let's just come back to the scheme to see where we are. Well, we have done this, and now we are at a point where we are going to update the answer. Now, this part is a little bit tricky, so we'll do it a little bit slowly. So now I'm going to write one more by block to say update answer, right? But like us, let's just recap. What I want to do is that as the word gets formed, I have this, guessed word that I'm creating, and I keep updating this with all the spaces. So that's the whole idea. I'm going to have to interchange between lists and words a little bit here. That's why this gets a little bit complicated. So for this purpose, I'm going to create a new list, and I'm going to call this list guessed word. So let's call it, say, guessed letters. And let's just say GUESSED letters. And the whole idea is that whatever letters I have guessed, I'll keep storing them in this list, right? But like in case of list, I must make sure that this list becomes empty when the flag is clicked. So I'm going to say delete all of this guessed letters when the game starts. So I'll say delete all of guessed letters. Now here is an interesting bit, right? I'm going to pre-assign this list with space bars, right? So basically I do not want this list to be completely empty. In fact, what I will do is that I'll repeat this 5 times because I have exactly 5 letters in my in the game that I'm developing. So I'm going to just put a repeat loop. Okay, I have to be careful here. I'm going to repeat this, say, 5 times. So repeat 5 times, add an empty item to the list, right? And this is important so that the list already has exactly the same length as the word, and then later on we can just use the replace command, right? This makes life that much easier, right? So I'm going to say, in the list of words, I'm going to say add. So I'm just going to say backspace this and just give a small space, right? So I've basically done a backspace and then given a space, right? So if I did this, notice what happens is the list has, in fact, item 5, has 5 elements, and those 5 elements are empty. Right? If I just did delete all of this, then the entire list will be length 0, right? I do not want that. I want the list to have 5 elements, so I just added a empty thing to the guest letters, right? Now with this, I'm ready to now create my third my block, but let me just declutter this a little bit. It's getting very confusing here. We've already seen these two. Okay, and I can have the guest letters coming up here, right? So what I will do is that I will now, now that the guest list has been created, I'm going to update this update this guest letters list once the answer has been given, right? So I again, all right. So now I'm in a position to create this my block called update answer. So I'll do that right now. So I'll say my block update answer, and this will have an input called letter, right? Because I'm going to update the answer based on the letter that the user has provided, right? So when I come to this my block, basically the idea is that I will now keep updating the user's answer, but for that purpose I'm going to first create a I'm going to convert all this that letter is giving, the user is giving, into a list guest letters, right? So here what I'm going to do, actually updating the guest letters, if you think about it, is exactly similar, is quite similar rather, I would say, to displaying the letters here, because I just have to know the right position where this letter has to go, right? So previously it was the X positions, and now I can make use of similar argument to update this guest letters list. So I can do it rather fast. I will use a counter variable here. So I'll say set, for example, I'm using counter 2. I can actually use counter, that's not a problem. So I'll say set counter 2 to say 1 here. Now I repeat it for the length of occurrences, right? Remember, this is very similar to the displaying of letters. So I'll say go and repeat for length of occurrences, right? So where's length here? Yeah. So repeat length of occurrences. And now wherever this, in the occurrences, so if it says 1 and 3, then I know that the letter appears at position 1 and position 3. So the position 1 and position 3 of guest letters, I'm going to replace this empty things with the given letter, right? So I can use replace item, right? And which item should I look at? Well, I should look at, item counter of occurrences. So I can use the variable here, item counter 2 of, so replace item counter 2 of occurrences of guest letters with this letter, right? Now think a little bit about this. This looks complicated, but really it's same thing as placing those letters on the XY grid. So once I do this, I must ensure that the counter 2 changes by 1, because I want to look at every occurrence of this letter, right? So I'll say change counter 2 by 1, right? Now with this done, let's see this working. So for that purpose, I'm going to just get my occurrences also in here, right? So that becomes easier for us. Still have to do one thing, which is that I have to call this update answer from my code. So I'll, this is getting a little bit messy here. So I'm just going to call this my block into say update answer, and here I will again use answer. Right, so let's just see this. Let's do this again. So if I did this, let's say the word is cycle. So I choose the letter E, for instance. Letter E occurs on the 5th position. That's why it appears here. And notice what happened, right? On the 5th position of this guest letters, I got a letter E, right? And why did this happen? Because I looked through this list. The first item was 5. So I went and replaced item 5 of guest letters with C. Now let's say I try C. C is present in 1 and 3. So that's why these two appear here. By a similar logic, in the guest letters, I get C space C and E, because 1 and 3, so item 1 of the guest letters becomes C, item 3 of occurrences, item 3 of guest letters becomes also a C because of this 1 and 3, right? So it's very similar logic, but now we have this list which contains the guest letters, right? Now, in order for us to compare the chosen word to the letters, I have two choices, right? One is that I can convert this chosen word into a list, or I can convert this guest letters into a word, right? Now I will choose the second approach because that's more logical. I can't compare a list directly to a word, right? These two are totally different data structures, so I cannot compare them. But I have all the information to now convert this into a word, right? So I have this, I'll convert this guest letters into a word. So I'll just update my update answers. Yeah, right here. So now that I'm using this counter 2 variable, once again, I can go and set, say, counter 2, and this part could be a little bit tricky, so think carefully about it. So I'll say set, say, for example, counter 2 to say 1. And now I'm going to repeat length of guest letters. Now this is important because I just want to look through this entire list and convert this into a word, right? So what I will do is that I will say, this time I'm going to say repeat length of, so now let's say in the variables, I'll go and say repeat length of guest letters, repeat length of guest letters. And I'm going to say, I'm going to create a new variable here, right? A variable here I'm going to create, which I'll call the guest word. Right now, guest word is the word, guest word, let's just call it guest word, is the word that user has been guessing, which I'm going to create from this list. Right now, what do I set this to? Well, in the beginning I must set the guest word to all empty, right? Because obviously it is it is it's fair, right, that in the beginning the user has not guessed anything. So I'll just go and say set guest word to, and in fact I'll make it empty over here, right? So I do that. Now over here, once the guest word is empty, I can use join apple banana to start forming this guest word, right? And what I do is that I go in here and I say set guest word to. Now, what I'm going to do is that I'm going to use join apple banana. Remember, the to start with, the word is completely empty. So if I just did this, for instance, join once again guest word. So I'll say join guest word to. Now, what should I join it to? I should join it to that specific item in the guest letter. So for example, I should just go to item 1 of guest letters, join this here, item 2 of guest letters, join this here, item 3 of just guest letters, join it here, all the way until item 5. So I can just say to join this thing to item here item counter 2 of guest letters, right? So I'll just say item counter 2 of guest letters, right? So this part will convert this list into a word, but important here again is that this is a counter variable. So I'm going to say change counter 2 by 1, right? Because I want to traverse every element of this list. Right now, this is quite interesting actually. So what is going to happen now is that we have a guest word which is now 0, but let's just see this once again. We will have a situation. So let's pick a word which is okay, so mimic, right? Now let's say I answer M. So M is present 1 and 3, it gets displayed here. Notice my word is M space M and space space, right? Let's just complete this whole thing. So let's say I now go and answer C. This time C occurs in position number 5. 5 appears here, and the guest letters 5 gets replaced. My okay, so I made some mistake here, right? It's become M M M M C. All right, so the mistake that I made here is actually quite interesting. So what's going on is that when I update the answer, I basically keep adding guest word to this list again, right? But remember, this list contains the entire history, right? So which means that when this my block starts, I must also set the guest word to an empty thing, right? So that it just kind of starts again, right? So I'll say set guest words to empty. It's exactly the same reason why we also emptied out the occurrences, right? So if I did this now, and let's just do this again. So let's say the word is gross. So I choose G, for example. G is 1. My guess word is G. If I choose now an S, occurrences is 5. S appears here. S appears in the guest letters, and I get G something 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 S. Right now, let's say I try W. So yes, G something something WS, right? It's occurred 4. Now notice that this time round, because I'm giving set guest word to an empty string over here, I'm not concatenating the entire I'm not sort of carrying the previous history, and in fact using it in a meaningful way, right? This guest letters contains all the history anyway, so the guest word has to just form every time newly, right? So for example, now I say R, and I finally say the O, so I will get a position where my guessed word has become equal to chosen words, right? So now at every point, like I said, this was the scheme. So now we are here, we have done all these three. We are here for the last part, which is to check for completion. And in fact, this part is quite simple, as we'll see it. So all I really have to do is that I can put an if condition over here, that, notice that after all these three my blocks, my guessed word would have been completed for the given letter. So I can put an if condition here, and I can say if guessed word is equal to the chosen word, right? So this part, because both are now words I can compare, so I can say if guessed word is equal to chosen word, I can just pull in this thing. So let's say chosen word is equal to, say, the guessed word. It means that the user is 1. So I can basically broadcast, let's say, celebrate and 1, right? Because the game is going to get over now. So I'm going to say use a broadcast and wait again. So I'm going to say broadcast and wait, and here the broadcast message that I'm going to do is to say celebrate, right? So I'll say celebrate. So broadcast, celebrate, and wait. And most importantly, I'll set my game over to 1, because the game has gotten over. But notice that because this is a broadcast and wait, so everything will happen before the game actually gets over, right? So I'll say set game over to 1, over here. And let's just completely, let's just complete this thing by seeing what we do inside these broadcasts, right? So I'll add a little bit of code as to what happens when I receive celebrate. Well, I can maybe, so let's just clean up this blocks a little bit, right? I can say when I receive, so with lists, gets a bit hard to maintain these blocks a little, but never mind. I can just say when I receive celebrate, right? I can just, maybe tell the user something, say very good or something like that, right? So I'll say change color effect, let's say, this is just for cosmetic reasons. So I'll say change, let's say, uh, color effect say by 25. I mean, again, just a number. And here I can use my text engine again to say write good job, right? So I'll say write, for example, good job, and maybe at minus 100 and minus 100, right? So minus 100 and minus 100. uh, on the other hand, if I, let's say, give a, so I have to also figure out if I have lost or not. So this is celebrate. Let's just complete this first, right? So if I did this, for example, now the word is dork. So if I just go DORKS, let's say, if I did this, notice I get this good job written over here. Now, on the other hand, let's say I could not answer these questions and the hangman became like to the last costume, then I can also have a broadcast created, and I can just broadcast a message called you lost, for example, from this particular hangman, right? So if remember the costume became 8, it means the game is over, and in fact I have lost. So I can just go and create a broadcast here. Once again, I'll use broadcast and wait so that all of that gets over before the game proceeds. So I'll say, here a new message, say you lost, and wait, and on the letters I'll go and add this when I receive, say when I receive you lost. Now here I want to display the correct word for the user so that the user knows what really happened, right? So I'm going to say reduce the size a little bit, so because those letters are appearing a little large. So I'd say set size to maybe say 100%. Again, change color effect by say 50 this time, so the letters appear a little bit different compared to the winning. So I'll say change color effect by say 50, right? And now I can use my, this my block here, so I can duplicate it a few times. I'll say right, let's say you lost, and I can do this, let's say at minus 80 and minus 75. Then I can also tell the user what the word was. I can duplicate this, so I can say the word was. Now notice all of this is going to get written as the game runs using our text engine. So I'll say minus 100, minus 100, and then finally I can write the actual word, right? And what is the actual word? I can just go and duplicate this and write in my chosen word, right? Because chosen word is the word that had been chosen, and I can write it, let's say at, okay, so here write chosen word at say, and these coordinates you have to decide obviously for your game, but anyway it just works, right? So now with this, we are done. In fact, I'm just going to close, obviously I'm going to hide this chosen word, and so maybe I'll let the chosen word be there so we can just test it once again. So I'm going to hide the game over. I'm going to, let's say, hide this also, and also I'll hide these lists, right? So with this, now we can try playing this game. So game starts. So the game is, let's say, okay, let's try something else. Must see. Okay, say avail, right? So we'll try avail. Now avail basically is, let's say I put A, I get two A's over there. I can say V, A, I, and L. If I did this, it said good job. Let's just try once again. So brain, let's say this time I'll just mess it up. I keep trying something, right? I mean, just randomly trying something just to get words over. It says you lost. The word was brain. Now notice one thing, that everything has become small here because we have set size to 100%. Now to fix this is very simple. When the flag is clicked, I'll just go and set the size to 200%, right? So I'll go here and say set size to 200%, right? Now with this, we are done. This is quite an interesting game, a lot of coding, a lot of lists, a lot of counter variables, but I hope you enjoyed this video. I hope you'll enjoy building this game as well. Take care. Thank you so much. Bye bye.